Hi everyone, it's Mr. Hamilton here, and in today's video we're going to look at what happens if we have exponents that are fractions or powers that are fractions. And so we looked at a number of these exponent laws in the last video, and today we're going to focus in on these powers that are fractions. So let's just go down to the laws that we had on this handout that were fractions. Now remember, another name for fractions is rational expressions, and so that's why we call these the rational exponent laws. Not like they're the only ones that that make sense logically, but they're just fractions. So keep that in mind here. Law number 8 says that if I have anything to the power of 1 over a number, then it's that root of the number. And so what this comes from, if you go back to the earlier law that we looked at, the power of a power rule, if I have 1 over n to the power of n, then, like, just think about this for a second. I could write this out as 1 over n, the power of n. That would give me a to the power of n over n. Well, that's just 1, a to the power of 1. And so we could rewrite that then, this part right here, as the nth root of a. And so that's where it's coming from. Now, as far as the example of this, an example would look something like this. We could look at, let's go 25 to the power of 1 over 2. And then you can see that whatever's in the denominator, we write it out in front of the radical sign. So we write a 2 out there, and then what's the base, we write under the radical sign. So the square root of 25, well, that's just 5. Likewise, I could do 125 to the power of 1/3. Well, that's the third root of 125, and that would give me, again, 5. And by all means, you could use your calculator to solve that. But what we're doing intuitively, too, if you wanted to try to do this without a calculator, is just saying, what number would I have to multiply by itself 3 times in order to get 125? Or over here, what number would I have to multiply itself 2 times to get 25? Now, some of you are noting that we don't usually write the 2 out in front of a square root. You don't have to write the 2 there, but it's not wrong to do so. Let's look at the one other rational exponent law. It's law number 9. And it says that if I have a to the power of m over n, so some fraction, not 1 over something, but a number other than 1 over another number other than 1, then what I do is, just like I did before, I've got whatever's in the denominator, I write out in front of the radical. And then whatever is in the top, I'm going to write inside the radical. And this follows, and you can see here from laws 3 and 8, where if I have a to the m, I can just separate this, because we know that anytime I have a fraction, it can also be written as this times that. I hope you agree that those are the same things. And so we've just separated those, and because the order of multiplication doesn't matter, I can put brackets here around a to the power of m. And so I get a to the power of m to the power of 1 over n. And we know that 1 over n is written as a nth root, and then we have a to the power of m. So let's look at an example or two of this too. So for example here, we could use the example of 64 to the power of 2/3. And you would look at this and say, well, that means that I'm going to take the third root of 64 to the power of 2. And so if you were to get this, you would have to square the 64. So 64 squared. So you take the third root of 4096, which is equal, if you take the third root of that, to 16. Now, I want to show you another way we can write this, and we're going to actually arrive at the same answer. If we instead write this as 64 to the 2/3, and we write this as the third root of 64 to the power of 2, we can take the root first. Watch this. If I take the third root of 64, I end up getting 4. And 4 squared ends up being 16. So I would encourage you for these questions, depending on if it gives you a nice number, take the root first. Otherwise, you're going to be dealing with some larger numbers, as we saw in this example. And this wasn't even that big of a number. Let's do a few more examples off this page, just so you can get sense for how this works before we take the last 3 up on the bottom here on the exercises. And before I do these 2 examples, I want to note that by all means you could type this in your calculator and get an answer. But remember, the key what we're trying to do here is not only learn about how our calculator works, but we're also trying to learn how the math works. And there are going to be cases where we don't have numbers in the base. There are going to be cases come tomorrow's lesson, our next lesson, we're going to have letters in the base. So it's important that we learn how these work and not just type these in our calculator. Also, I expect you to show me the steps for full marks on questions like this, as any teacher likely would. All right, so negative 27 to the power of 4 over 3. So you remember I said a minute ago that it's easier generally to take the root first and then take the power after that. So we're going to take the power of 4 after we take the root of negative 27. Now some of you look at that and say, well, you can't take the square root of a negative number. We're not taking the square root of a negative number. We're taking the cubed root, or the third root of a negative number. In other words, we're asking ourselves, and I'll write this carefully below just so you don't get tricked by this, how, or what number times itself 3 times gives negative 27? Which number times itself 3 times gives negative 27? Well, in this case, negative 27 would be the result of negative 3 times negative 3 times negative 3. And again, there's nothing wrong with using your calculator to take that cubed root, but also, if you can do it more intuitively, you'll start recognizing some of these numbers as they come up more and more in our homework, and you won't need to type it in your calculator every time. You should be able to start processing some of this with your brain as well. So now negative 3 to the power of 4, well, this is going to become positive now, and it's going to become positive 81. This next one isn't a fraction. So what do you do if it's not a fraction? Well, you turn it into a fraction. So this becomes 16 to the negative 3/4. Now the first thing I'll note is that if it's a negative, it's going to bring it to the denominator. So it's going to become 1 over 16 to the 3/4. Right? This was our reciprocal rule that we looked at in our previous lesson. And so I'll just reiterate that for you one more time. Just a very simple example. If we had 2 to the negative 1, that was 1 over 2 to the power of 1, which was 1 over 2 in that case. So in this case, it's the same idea, but now we have this fraction as the exponent. So again, I'm going to take the root first. So I'm going to take the 4th root of 16 first. And then after I take the root, I'm going to cube it. So the 4th root of 16 is 2. 2 cubed is 8. Now remember, you could have also gone the other direction with this. We could have instead gone 16 cubed and then taken the 4th root of that. If you'd done that, 16 cubed would have worked. It just would have been a little uglier. So you would have gotten 1 over the 4th root of 4096. The 4th root of 4096 is 8, and you also would have arrived at 1 over 8. So those are some examples of that. Let's look at one final fairly difficult example, and then we'll take up those 3 questions on the exercise portion. So first look at this question might say, hey, I'm just going to type in my calculator and get an answer. But what we're going to do here in this question, I want you to try it on your own first. We're going to use a lot of the rules here. We're going to use the power of a power rule. We're going to use the product rule. We're going to use the quotient rule. We're going to use the rational rules. All these are going to be used. So go ahead and try to simplify this. Get one, because they're all 9s. Let's see if we can write them all to exponents. Simplify it by bringing them all with the same base to one single exponent as a fraction, and then get an answer from there. So go ahead and try that. Pause the video, and then you can watch what I do after that. So hopefully you have an answer to try this out yourself, and hopefully you've got an answer of 3. Let's see if you get the same. So in this first one, we're going to write it out as an exponent. So this is 1/3 times 9 to the power of 5/6. Down here, this is the power of a power rule. This is 9 to the power of 2/3. I'm just going to take a moment to write these out. This is law number 8. The next one that we used, if you want to look back at your sheet, if you need to refer back to it, this is the power of a power rule. So it actually has a name, power of a power rule. And this is law number 3. And now we're going to go ahead and we're going to use the product rule. So that's going to be the next thing. We're going to simplify what's in the denominator or the numerator here. So I'm going to go 9 to the power of 1/3 plus 5 over 6. This was our first law. And I'm going to keep it divided by 9 to the power of 2 over 3. Now, 1/3 plus 5 over 6, I need a common denominator to add those, so I'm going to write it as 2/6 plus 5 over 6 divided by 9 to the power of 2/3. And then 2/6 plus 5 over 6, doesn't look like a 6, but it's 6, is 9 to the power of 7 over 6. And we're dividing that by 9 to the power of 2/3. And now we're going to use the quotient rule. I'm going to do that up here. Wow, that was a cool diagonal. This is quotient rule. And the quotient rule is our law number 2. That was the second one we saw on our sheet. And so that is equal to 9 to the power of 7 over 6 minus 2/3. Again, I need a common denominator to subtract these. So 7 over 6 minus 4 over 6. And this gives us 7 minus 4 is 9 to the power of 3 over 6. Well, we can simplify that to 1/2. And now we're going to use law number 8 again, but in the opposite direction. So we're using this rational law. And this becomes the square root of 9. You can put a 2 there, you don't have to because it's just the squared. And the square root of 9 is in fact 3. So there you go. We can use all these laws to simplify something that looks fairly complicated into something that's very nice and simple. Oftentimes in the homework, if the answer doesn't work out nicely, you've probably made a mistake. So be checking your answers regularly as you do the homework. And let's go back now, try the last 3 questions on that handout with the laws, and let's take those up and see how you did. So these should be relatively straightforward in light of the questions that we just did, but do them again. If you haven't paused the video, do pause it and check your answers when you get that. The first one is the third root of 27. The third root of 27 is what number times itself 3 times gives you 27? Well, that number is 3. 3 times 3 times 3 is 27. The next one is the fifth root of negative 32. And what number times itself 5 times gives you negative 32? It's negative 2. And the next one here, 1/8 to the power of 1/3, is saying I've got 1 to the power of a third. Well, that doesn't matter. 1 to the power of anything is 1. And 8 to the power of a third. And so it's 1 over the third root of 8. And the third root of 8 is 2. So it's 1 over 2. So there you go. Any questions, as always, reach out, ask for help. Happy to help.